Code and the BBC Microbit. I'm your instructor, Dave Semelink from GoDigitalSA Foundation. And today we're going on with Unit 7, Coordinates. So, Lesson A is Understanding Coordinates. And what we'll learn, the microbit coordinate grid and how it can be used. So, let's first take a look at coordinates in math. Okay. We've got axes. The basic coordinate grid has two axes, an x-axis, which runs horizontally, left to right, and a y-axis, which runs vertically, up and down. And there's an origin. The two axes meet at a point called the origin, where both the x and the y values are 0. On this basic coordinate grid, the origin is in the lower left corner of the grid and has the coordinates 0, 0. Okay, so you might remember from math that we've got a coordinate system here. The origin is 0, 0. The x-axis goes along here. The y-axis goes up like this. Okay, coordinate pairs. The first value in a coordinate pair is the x value, and the second value in a coordinate pair is the y value. So it's in parentheses x comma y. Coordinate value changes. The value of the x-coordinate increases left to right and is a measure of how many units a point is horizontally from the origin. The value of the y-coordinate increases bottom to top and is a measure of how many units a point is vertically from the origin. Okay, so if we got a point over here, its coordinates are 1, 1, because it's 1 across the x-axis and 1 up. Okay, over here is 2, 2, 3, 3, 4, 4. And you'll see that little note here, not so with the microbit. Okay, so coordinates in the microbit, coordinate grid on the microbit. The 5 by 5 grid of LEDs on the microbit represents a coordinate grid with a horizontal x-axis and a vertical y-axis. It has an origin, and you can refer to the position of the LEDs with coordinate pairs. There are similarities and differences between the microbit coordinates grid and basic coordinate grids in math. Okay, so if you take a look here, these are the coordinate pairs of all the LEDs. So similar to the coordinate grid in math, the values of the x-coordinates range from 0 to 4 and increase from left to right, just as they do in the coordinate grids used in math. The differences from coordinate grids in math, the origin 0, 0 is in the top left corner. The values of the y-coordinates range from 0 through 4 and increase from top to bottom. So you'll see that x increases as you move to the right, so 0, 1, 2, 3, 4, but y increases as you go down instead of up. So y is 0, 1, 2, 3, 4 going down. Okay, a little bit of history here. René Descartes, he lived from 1596 to 1650. He was a French philosopher and a mathematician who developed the coordinate system we use today. A story goes that while lying in bed, he noticed a fly on the ceiling. In wondering how he could describe the fly's exact position on the ceiling, he decided to use a corner of the ceiling as a reference point, and then describe the fly's position as a measure of how far away from the reference point one would need to travel horizontally and then vertically to reach the fly. His coordinate system proved useful in many ways, including creating an important link between the studies of algebra and geometry. Geometric shapes could now be described by points on a coordinate plane. Okay, so let's review. What is the location? What location is the origin on the microbit screen? It's the top left corner. What is the range of x values on the microbit screen? And what direction do they increase? Okay, they go from 0 to 4, and they increase as you move to the right. What is the range of y values on the microbit screen, and what direction do they increase? They go from 0 to 4, and they increase as you move down from the top left corner. Good. Battleship. in pairs, play the game Battleship using a 5x5 coordinate grid drawn on 2 pieces of paper from 00 to 44, just like the microbit screen. Plot where your ships are on your grid. Players call out shots using XY coordinate pairs. Okay, I don't know if you know the game Battleships. The Battleships, you've got a coordinate grid, and you have ships at various places on the coordinate grid, and then you try to sink each other's battleships without knowing where they are. Okay, so what we learned today, the microbit coordinate grid and how it can be used. The next time, we'll code animations and patterns and assess our learning with a quiz. Okay, so that's lesson B, coding animations and patterns. And what we'll learn, we'll use coordinates to create animations and patterns and review how much we've already learned. Okay, so the smile animation, create a smiling and non-smiling face with show LEDs blocks. Now recreate this program using the LED plot coordinate blocks. Hints, what LEDs change between the two faces, and use the LED toggle block for the LEDs that change. Okay, so your program may look something like this. Okay, so we start by plotting these points. So x is 1, y is 0, x is 3, y is 0, and so on. And then inside the forever loop, we'll toggle. That means switching it on if it had been off, or switching it off if it had been on. So it will toggle the LED at 0, 2, and at 4, 2. It'll pause a quarter of a second, and then it will toggle the one at 0, 3 and the one at 4, 3. So mods, add a third image to the animation, perhaps a frown face. Make your own custom animation. What LEDs stay the same and which need to be toggled. Okay, and here's a random pattern generator. The pseudocode is on button A pressed. Use a loop to turn on a random set of LED lights on the microbit. The display will have one LED lit for each column or X coordinate value from 0 through 4. Okay, so you can see here that they're flashing in random, but there's always just one LED in each column. There can be more than one LED on in each row. Okay, so our program can look like this. We clear the screen, and then we use a for loop. We plot an LED, use a for loop index as the X value, use a random number from 0 to 4 as the Y value. Okay, so when you press button A, it clears the screen. And then for index from 0 to 4, we plot X using index. So it's going to be 0, 1, 2, 3, and then 4. And Y will be a random number from 0 to 4. Okay, code button B. Check whether a certain LED is lit. So you use an if then else block to check whether LED 0.00 is on. If so, display a yes check mark, else display a no X mark. Okay, so when you press button B, it checks to see if this point is on, then it should show a check mark, otherwise it should show an X. And then we can modify this. We add a loop to test for all coordinates on the microbit when button B is pressed. Okay, so we'll have a loop and go through all the different values of X and Y. And brightness. So set the brightness level for the LEDs to the highest level on start, and use A to decrease the brightness and B to increase the brightness. Use button A and B pressed together to check and display numerically the current brightness level. Okay, so on start, we set the brightness to 255, and then we show any icon. Then we reduce the brightness whenever we press button A, increase the brightness when we press button B, and when we press them together, we show the brightness value. Okay, it might look something like this. So on start, we set the brightness to 255 and we show an icon. When button B is pressed, we set the brightness to brightness plus 25. On button A pressed, we set brightness to brightness minus 25. And when A and B are both pressed, we clear the screen and we show the value of brightness. And then we just show an icon again. Okay, we can modify this. What happens if adding 25 or subtracting 25 from the current brightness level would result in a sum or difference outside of the 0 to 255 brightness range? Add code to protect that from happening. Okay, brightness can be anything from 0 to 255. If it's below 0, we might have a problem, and if it's above 255, we might have a problem. So when we add 25 to the brightness, we need to first check to see if it's already over 255. If it is, then we can't increase it anymore. We leave it at 255. And likewise, before we subtract 25, we have to see if it's 0. If it is, we leave it at 0. Okay, let's open a browser and start coding. Okay, so we're back in make code on our browser, and we are going to create a new project called Unit 7. Okay, and we want to draw a smiley face and then have it change into a face that isn't smiling. Now, the easy way to draw a face would be with show LEDs. Okay, we would draw a face. It might look like this, something like this. Okay, but now we want to work with coordinates, and so we're going to draw it one at a time. Okay, we're going to do this with a LED drawer, and we're going to plot. So I'm going to leave the show LEDs here so we can see which ones we need. We need to plot 1, 2, 3, 4, 5, 6, 7, 8 LEDs. Okay, so we can duplicate this 8 times. Okay, and we're going to draw this by plotting each LED. So you'll see that the first one that's on, X is 1 and Y is 0. So we make X 1 and Y 0. The next point, X is 3 and Y is 0. Okay, so we make that 3. Okay, the next one, X is 1, X is 2, 0, 1, 2, Y is 1. Okay, the next one, X is 0, 1, 2, and Y is 0, 1. So it's 2, and 1. Next one, X is 0 and Y is 0, 1, 2. That one, X is 4 and Y is 2. Okay, next one, x is 1, y is 0, 1, 2, 3. Next one, x is 2, y is 3. Finally, the last one, x is 3 and y is 3. Okay, so this will draw this face. We can now remove this. Well, okay, so now we want to change it to a frown. So I'm just going to draw it here so we can see it. Okay, not really a frown, but just a plain face. Okay, so having drawn the smiling face, we now want to change between the smiling face and this face. Okay, so to change between the smiling face and the frowning face, we want to turn this off and this on, this off and this on. Okay, and we're going to go between the smiling face and the frowning face. Okay, so in this case, we want to toggle. So we're going to toggle x is 0 and y is 0, 1, 2. And we're going to toggle x is 0 and y is 3. And we're toggling x is 4, y is 0, 1, 2. And we're toggling x is 4 and y is 3. Okay, I can now remove the show LEDs because we want to use plotting to do this. Okay, so when we start, it's going to draw the smiling face. And then in this loop forever, it's going to change between the smiling face and the not smiling face. We just want to put a pause in here. Okay, so we can see it happening. Okay, so now you see what's happening. You get a smiling face and then a not smiling face. Maybe we can slow that down a little bit more. Okay, so on start, we get a smiling face. We've plotted all the points for a smiling face. And then in this forever loop, we toggle those LEDs so that we go from a smiling face to a not smiling face and then back to the smiling face. Okay, so that's our smiling face to the not smiling face. And for one more modification, we can say make a frowning face. To make a frowning face, we now want to turn this LED on and that LED on and turn those off. Okay, this could be a little bit more complicated. Okay, so we had a smiling face. It becomes a plain face. Now we want to change the plain face into a frowning face. So we have to toggle this one. So that's x is 0 and y is 0, 1, 2, 3. Okay, which is we've got over here. Okay, 3. And x is 4 and y is 3. 0, 1, 2, 3. And then we want to toggle this one. So x is 0, y is 4. X is 0, y is 4. And this one, where x is 4 and y is 4. Okay, so once again, on start, we've drawn the smiling face. And then in this forever loop, we're going to go from smiling face to a plain face, then plain face to a frowning face. Okay, let's just see what this does. There is a problem, but let's just see. Okay, so you can see that it worked once, but now we get this funny look. So we need to go from the frowning face back to a smiling face. Okay, so we have to turn off the frown, which was that x is 0, y is 4. Turn off the one that's at x is 4 and y is 4. And turn on the smiling face, so that x is 0 and y is 2. And this one, where x is 4 and y is 2. Okay, and we finally have to put a pause in there. Okay, so again, on start, it does a smiling face, then it turns it into a not smiling face and waits. Then it turns it into a frowning face and it waits. Then it turns it into a smiling face again and waits. So we're back with a smiling face. This forever loop will then change to not smiling, frowning, smiling, not smiling, frowning, smiling, and so on, forever. Okay, and you can see that. Okay, and before we go on, I just wanted to mention that the principles we see here are the same as you would see on a personal computer or an Xbox or a game machine, where you've got a screen that has got lots of pixels, not just 5 by 5, but it works in exactly the same way. If you're creating a game, you can plot the points to make characters that move around and make animations on the screen. Okay, so we'll save that. I'm going to call this Unit 7 Animation and save that. Okay. Okay, so time for a quiz. So how many coordinate pairs are represented on the microbit LED screen? Remember, there's 5 LEDs in every row, and there's 5 rows. So that's 5 times 5 or 25 LEDs. So there will be 25 coordinate pairs. Okay, we want to mark the LED location represented by these coordinates. So you got 0, 2. So that's 0, 1, 2. This one, 3, 0. So 0, 1, 2, 3. 3, 0 is here. 1, 3. So 0, 1. And 0, 1, 2, 3. So that's this one. And 4, 4. So it's 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Okay, like that. What type of variable is the XY coordinate? Okay, this is a sprite. It signifies the position of the LED on the microbit screen. So we call that a sprite. So the type of variable is a sprite. Okay, we've learned how to light LEDs on the microbit screen using blocks from 3 different toolbox drawers. What are the 3 toolbox drawers? Okay, so we saw basic, where we've got show LEDs, show icon, LED, where we can plot, unplot, toggle, and point, and game under advanced, where we have sprite move by and sprite turn. Okay, how would you describe this code with words as pseudocode? Okay, so in our code, we've got on button A and B pressed. If point x2 and y4, so that's the coordinates 2, 4. So if that point is set, then it shows a smiling face. Otherwise, it shows an X. Okay, so we can just put it like that. When button A and B are both pressed, if the point at x equals 2, y equals 4 is set, then show a smiling face icon, otherwise show a X icon. Okay. Okay, so what we learned, use coordinates to create animations and patterns. Okay, and for a project, you can try to make a screensaver or a game project. Okay, you can try that at home. You code a microbit program that uses coordinates to make a screensaver or a game. Okay, you use what you know about LEDs, coordinates, and brightness to create your own screensaver or game. So you create a screensaver animation using the plot, unplot blocks. You can fill the screen line by line, pausing between each one, or fill it with a random constellation of stars. Or you can create a game that uses sprites to manage the X and Y coordinate values of the different objects. Okay, so these are some project ideas. You can make a fireworks screensaver, so just try to make the LEDs light up like fireworks. A cascade screensaver, which makes a diagonal cascading effect, or dodgeball game. Okay, so this uses one sprite to try to avoid another sprite. You use the A and B buttons to move the dodger to avoid the balls that are falling from the top of the screen. Okay, and again, use a design thinking approach and ensure the project meets these specifications. Use at least 3 of the different kinds of plot, unplot, toggle, point, XY blocks, and uses variables to update the coordinates in some way. Uses plotted LEDs in a meaningful way. The program compiles and runs as intended and includes meaningful comments in the code. And, right. Okay, so what we learned today, we coded a microbit program that uses coordinates to make a screensaver or a game. Okay, so the next unit 8, we'll be looking at Booleans. Okay, that's all for now, so I'll see you next time.